Hi students, I'm going to go over the review questions, so just have it handy. If you have any questions, feel free to ask me right before the test or come to tutoring at some point. Please use this review to help you. You don't have to watch every single problem unless you're stuck on a problem, or if you just want to check the answers, you can just fast forward to the solutions. Okay, for number 1, it's asking you for that correlation coefficient. Remember, this is represented by the letter R and can only be found on the calculator. So what you'll have to do is you'll have to go to a new document on your calculator. And if you're at home right now, you can do it when you get back to class. You will open a new document, go to Lists and Spreadsheets. You will list all of the first column in one column and all the data in the second column in the other. Make sure you label the tops of each list with X and Y. After that, you will enter, make sure you are in a blank blue cell before you do the next part, and you'll just type menu 413. That will always give you that correlation coefficient as well as the slope and the y-intercept if you do need to write the equation. When you type menu 413 for this particular data, the R value equals -1. Remember, the R value always is going to range between -1 to 0 to 1. It will be somewhere between -1 and 1. If it's at -1, that means there is a very strong, it's the strongest kind of negative correlation. If it's at +1, that's the very strongest positive correlation. If it's at 0, there is no correlation. As you move from the -1 and the 1 towards the 0, it gets weaker and weaker. So because we have exactly a -1, that means it's the strongest kind, and because it's a negative number, it's a negative correlation. For number 2, you are given a function rule. G determines M, or we could say M, the miles, depends on G, the number of gallons of gas we have. What they're asking is which table of values is represented by this function rule. So you can type this into your calculator and look at the table, or you could also just kind of think what it means. This is a very simple function. Basically, you're taking G and multiplying it by 23. So if you look at the G column for each table, and you multiply each of those values by 23, and you just go all the way down, you can kind of see if it makes sense. So like if you look at letter choice A, 0 times 23 is 0, okay. 1 times 23 is not 13, so I'm going to immediately eliminate this choice. Now we go to B. 0 times 23 is 0. 1 times 23 is 23. 2 times 23 is 46. 3 times 23 is 69. So this table actually works. Okay? Double check with the other answer choices. Don't just go with the first answer choice that works. You always want to make sure that you didn't make a mistake. So go back to the other one. So like on C, I take my G column times 23. 0 times 23, of course, gives you 0. So that's true for both C and D. But 1 times 23 gives you 23, not 20, and not 17. So you can just kind of double check with yourself to make sure that the other answer choices are not correct. Okay, if you want to actually write these out, you can use your function notation. You could say, okay, when my G is 0, when my input's 0, I'm going to have 23 times 0. Well, that's going to give me 0. That should be my first output. Okay, then I can go to the next input, 1. I'm going to replace X with 1. So now I'm going to do 23 times 1. Well, that equals 23. That should be my second output. And you can just go through each one. When my input is 2, I'm replacing the G with 2. So 23 times 2 is 46. That's my third output. And then my last input is a g of 3. Replace my g with 3. 23 times 3 is 69. That's my last output. So I can see these 4 values in the output column. Remember, the output column is your y. Okay? Okay, when you're finding domain and range from a graph, you need to first consider, is my graph discrete or is it continuous? If there are just dots on your graph, it is discrete. If there is a line that connects all the dots, that's continuous. So this graph is continuous. When you have a continuous graph, the domain and range is going to be an inequality. When you have a discrete graph, though, it's just going to be a list. So in this case, we're going to do some kind of inequality. So remember, you're always going to have your curly brackets. So we're going to want that for both. Our domain, remember, that's all of our x values. So you are only going to be looking at this x-axis when you're determining the domain. Okay? So my domain, and according to this graph, I don't know if there are arrows at the ends of my arch here, which is called a parabola. So I'm going to just use what I've got. Okay, since there are no arrows at the end, I'm going to say that it stops right around here. Right, this is the far left part of my graph, and then the far right part of my graph is right here. So to me, based off the information I have, the best guess I can say for my domain, my smallest x value is going to be -1.5 or 1.5. Then you always put your less than or equal, less than, equal, or less than. You would only put just a less than without the equal sign if it was an open dot. Since I don't have that, I'm going to keep my little equal sign. Domain is x, so I always put x. Then I'm going to put my less than equal again because I don't have an open dot. And then my far right value is going to be 4.5 or 4.5. And then close it with your curly brackets. For my range, let me erase some of this stuff. For my range, we're only looking at the y values, so make sure that you don't even look at the x-axis. For the range, I'm going from the very bottom of my graph all the way to the top. The very bottom of my graph has a y value of -5, and the very top of my graph, like if this was a mountain, I'm going to say it's right there around 4. So those are going to be the values that I put at the ends of my inequality. So the low value, like we said, was -5. Put your less than equals. For range, we use y, so you want to always make sure you're looking for y for range if it's a multiple choice question. Put your less than equals, and then the very top value would be +4. So this question is kind of like a conceptual question, and then in a little bit here we'll actually do examples to figure this out. So far we've learned 2 ways to find slope. We can find it on a graph, and we can find it given 2 points without the graph. Let's talk about with the graph. With the graph, what you're going to do is you're going to find the rise, and you're going to put it over the run. You're going to make a fraction, and that's how you'll find the slope. Remember, the slope we represent with the letter M. The rise would be how far I go up or down from one point to get to the other. So first you have to choose which point am I going to start with and which point am I going to end with. From that point, do I need to go up or do I need to go down to get me closer to the second point? If you go up, this number is positive. If you go down, this number is negative. Once you've gotten a little closer to the point, now I'm going to run, which means I'm either going to go to the right or to the left to get closer to my second point, or to get to my second point. If I go to the right, that's going to be a positive number, and if I go to the left, that's going to be a negative number. Make sure that you remember, if you have a negative anywhere in your slope fraction, whether it's in the top or in the bottom, that means the slope is negative. So you always want to check that. Remember, negative slopes are going down from left to right. If you have no negatives, it's positive. Or if you have a negative in the top and the bottom, the slope is positive, and that goes up from right to left, or sorry, from left to right. If your slope is completely flat, it's got a slope of 0, and if it goes up and down, it's completely vertical, it has no slope. So I want you to remember we drew this guy in class, Mr. Slope Face. I'm going to draw him for you real quick. He looks like this. He's got two little worried eyebrows. One eye is a plus, one eye is a minus. That helps you remember what those slopes look like. Positive goes up, negative goes down. His nose is very straight up and down. We say if a line's going up and down, it has an undefined slope. So we put a U there for the end of his nose. And then if we have a line that is flat or horizontal, we say that it has a slope of 0, 0, 0. Okay, so to me that's his mouth and then a little soul patch beard. Now let's talk about, well, how do you find slope given 2 points and no graph? If you have graph paper handy, you can always graph the 2 points and then do what we just talked about. Sometimes those numbers are really big or we don't have graph paper handy, so what we're going to use is we're going to use the slope formula, which basically says how to find your y, so how to find your rise in the top, which means you subtract your 2 y values, and how to find your run in the bottom, which is when you subtract your 2 x values. What I've told my students is don't worry so much about the 1s and 2s, just make sure that whatever number you're subtracting from, like the first number in the y and the first number in the x, these 2 numbers just need to be from the same point, and then the second numbers, the numbers you're subtracting, need to both be from the other point. So as long as you're being consistent in the top and the bottom, in the order you're subtracting, you will get the right slope. Alright, remember range. Range indicates y, so we're only going to be looking at the y-axis, the numbers on the y-axis. Don't even look at the x-axis. Okay, so we're looking for the bottom of my graph, which is this point down at the bottom. That has a value of -3. And then we're looking at the very top of my graph, which is this top point. It has a value of 4. Because this is a continuous graph, I'm not looking for a list, so I'm going to eliminate F and J. I also don't have any open dots, so I need to make sure I've got equal signs. Both of these have equal signs under my less thans. I need -3 for my small number and +4 for my large number. So my answer here is going to be G. Okay, let's try another one. Again, this one is also asking for range, so we're just looking at the numbers on your y-axis. The very bottom of my graph down here has a y value of -3. The very top of my graph up here has a y value of +3. Now notice the very top point right here is an open dot. So at the +3 on the right side, or the larger number, I do not want to have the equal sign. Okay? So I want it to look like this right down here. The lower number, like we said, was -3, and I do want to have the equal sign because that's a closed dot. So my answer choice for this range is going to be D. Here is an example of finding domain. So remember with domain is just the x values. So I'm just looking at my x-axis numbers. I'm not even looking at my y-axis. It says that my domain needs to be all numbers greater than 7. Greater looks like this, right? It does not equal. If it equaled as well, it would say greater than or equal to. So I'm looking for an open dot here. And it looks like all my answer choices have an open dot, so I'm good. But I'm only looking for x values that are greater than 7. That means to the right. Notice how my greater than symbol kind of points to the right. So I'm looking for my graph to go to the right from an x value of 7. So if I find 7 on my x-axis, whoops, it's right here, and I'm looking to see that the graph goes to the right. This one goes down, this one goes up, This one goes to the right, but it's starting at 0, not 7. So this is the graph that I want. It starts at 7 and goes to the right. So A is my answer choice here. Okay, let's practice finding slope from a graph. If you don't have 2 points from the line labeled for you already, you want to look to see where your graph intersects the grid intersections. So for this one, this would be a good point, and this would be a good point right here. Okay? You want to start at one point and go to the other. It's totally up to you which point you want to start with. If I start with this one right here at 0, 3, and I want to go to the point at 2, 0, I'm going to first think about my rise. My rise is up or down. So to go from the 0, 3 to the 2, 0, I'm going to have to go down 1, 2, 3 spaces. Make sure you're counting the spaces, not the line. And because I went down, that's a -3. Now I need to go to the right. This will be my run. So I'm going to go to the right. That's positive. So I'm going to go 1, 2, because I went to the right. Like I said, it's positive. So my rise was I went down 3, or -3, and my run is I went to the right 2, or +2. So this is going to be the slope of this line. And it's completely simplified, so we're good to go. Also make sure after you found the slope from a graph that you kind of verify this line was going down from left to right, which means it does need to have a negative slope, which we have. So we are good to go here. This graph is going up from left to right, which is positive, so we need to kind of double check our answer and make sure that we get a positive slope. These points are actually labeled, so I can use the 2 that are labeled. I'm going to start with one and go to the other. If I start with A and go to B, for my rise, I'm going to have to go up, not down, and I go up 1, 2, 3, 4 spaces. Because I went up, that's a +4, so that's my rise. Now I'm going to run, that's side to side. This time I'm going to go to the right 2, 1, 2. That's also a positive number. Now this fraction can be simplified. You can use your calculator to simplify, or you can kind of just do it in your head. I know that both of those numbers can be divided by 2. Remember, the way you simplify is you divide the denominator and numerator by the same number. 4 divided by 2 is 2. 2 divided by 2 is 1. So my slope is 2 over 1. You could also just say your slope is 2, but it's a good practice to get into representing it as a fraction. And yes, this is positive, so that means we did it correctly. When your line is going completely horizontal like it is here, or completely up and down, you should immediately know the slope. You don't have to count boxes or anything. This slope is horizontal. That means it has a slope of 0. You also want to kind of get into the habit of thinking about what the equation of the line would look like. Because it's going through the y-axis at +1, its equation is y equals 1. Now, because it's also a function, if I wanted to, I could even call it f of x equals 1. Because remember, when we have a function, we can replace the y part with the f of x notation. So just kind of keep that in mind. Horizontal line is always y equals whatever number it goes through on the y-axis. This line is completely vertical, so make sure that you remember in a vertical line there is no slope. Or you can say that it is undefined. Okay, so you have to remember, don't get the horizontal and vertical lines mixed up. You also want to think about what the equation of the line is, because this line goes through the x-axis at +1. Its equation is x equals 1. All vertical lines will start with x equals and then whatever number it passes through on the x-axis. Now we're going to do an example of finding slope from 2 ordered pairs without the graph. Like I said, you could graph these and then count the rise and run. But you can also just use the formula. It's pretty simple. what I always tell my students is first always label the points x, y, x, y. Don't worry so much about the 1s and the 2s. I think that's a little more complicated than we need to get. But what we're going to do is we're going to go ahead and subtract them. Remember that we're subtracting our y's on the top and our x's on the bottom. Our two y values are 7 and 1. We can choose to do 7 minus 1 or 1 minus 7. I'm sure a lot of students will probably gravitate towards the one that's going to give us a positive number. When you're finding slope this way, make sure you're always subtracting. Sometimes students mess up and add. So because I chose to subtract my y's from left to right, I need to subtract my x's in the same way to be consistent, also from left to right. My left x value is 3, and I'll subtract the right x value of 10 from it. Now we just have to simplify. 7 minus 1 is 6. 3 minus 10 is negative 7. So my slope is 6 over negative 7. Now, if you subtracted the other direction, you did 1 minus 7 in the top and 10 minus 3 in the bottom, you're going to get negative 6 in the top and positive 7 in the denominator. These both mean the exact same thing. As long as there's a negative somewhere in the fraction, just one time, then that means the slope is negative. Remember, if you have two negatives, like one in the numerator and one in the denominator, that means the slope is positive because a negative divided by a negative is a positive. All right, let's try another one. Label your ordered pairs with x and y, both coordinates. Choose whatever direction you want to subtract in. I'm looking at my y's. I've got a negative 7 and a 12. I think I'm going to do 12 minus negative 7. When you're subtracting a negative, make sure you put that negative in parentheses so that you remember. So I've chosen to subtract from right to left. So when I do my x's in the bottom, I need to subtract in the same order. My right x value is 3 minus my left x value is negative 1. So now we're going to simplify. When you subtract a negative, that's the same as adding a positive. 12 minus negative 7 would be the same as 12 plus positive 7. What I used to do in junior high when I would teach this is I would tell them take the two negatives in that parentheses and just make it into a big plus. We can do that down here as well because we're also subtracting a negative. So now what we have is 12 plus 7 in the top, which is 19, and 3 plus 1 in the bottom, which is 4. So I have a slope of 19 over 4. If you want to check this by graphing these 2 points and actually counting the rise and the run, you should get this, this slope. All right, let's try another one. X, Y, X, Y. I'm going to come down here now. Actually, I need a different color. That's too dark. Okay, let's try it again. So my y values are both 17. They're the same. So that means I can subtract right to left or left to right. Either way, the numerator is going to be 17 minus 17. So in the denominator, I'll just do 8 minus 2. What's going to happen in the numerator is we're going to get 0. Our denominator is going to be 6, or it will be negative 6 if you subtract it the other way. But it doesn't matter. If your numerator is 0, 0 divided by anything is 0. That means we have a slope of 0. This graph is going to be horizontal if I connected these 2 points. So my slope is 0 here. All right, let's try another example. X, Y, X, Y. My y's are negative 7 and 6. I can do negative 7 minus 6 or 6 minus negative 7. I think I'm going to do 6 minus negative 7. So I'm going from right minus left. I need to do the same order with my x's. My right x value is 12 minus my left x value is also 12. So what I'm going to get in the numerator, I'm subtracting a negative like we did a minute ago. I can make that into a big plus because that's the same as adding a positive. 6 plus 7 is 13. 12 minus 12, though, is 0. When 0 is in my denominator, that's different than when it's in my numerator. When it's in the denominator, we cannot divide by 0. If you put it in your calculator, it'll just tell you that it's undefined, or we have no slope. Either way you want to write it is fine. Undefined or no slope. They mean the same thing. No slope and zero slope, though, are very different. Zero is a number. No means it does not exist. Okay, in this example, we are given this function, f of x equals 2/3 times x squared plus 8x, and it wants to know the value of f of 6. Because 6 is in my parentheses, it's my input. So to get my output, I want to plug it in to the two places of my function rule where I see x. So this is how we write it. F of 6 equals. Whenever you replace a variable with a number, make sure you always put it in parentheses so that you'll evaluate it correctly. 2/3, instead of x, though, I'm going to put 6, and then square that, plus 8 times 6. To evaluate this, you can either use PEMDAS, or you're welcome to type this part into your calculator. If you use PEMDAS, though, you have to follow it. So remember how PEMDAS works. P stands for parentheses. That means simplify what's inside of the parentheses. Our parentheses are already simplified. E is exponents. We have an exponent of 2, and the only thing that's raised to it is 6. 6 is its base. So we're going to do that first. So we have 2/3 times 6 squared. 6 squared means 6 times 6, which is 36. Okay, the next thing we're going to do is multiply or divide, and you do these at the same time from left to right. So the first thing, we have 2/3 times 36. The way you multiply a fraction times a whole number is you put the whole number over 1. So we're going to do that. You multiply your numerators together. 2 times 36 is 72 over, multiply our denominators together. 3 times 1 is 3. And then the other thing we multiply is 8 times 6, that's 48. We can simplify 72/3 to 24. And then the very last thing we'll do is you add or subtract from left to right. 24 plus 48 is 72. So when our input is 6, our output is 72. Whenever you have problem situations, make sure you're reading very carefully. For this one, C represents cost in dollars, T represents number of tickets. So they want to know if our cost is 83, what's our tickets? So C is our cost, we need to find T. So basically when our output is 83, right, so I'm replacing C with 83, we need to figure out what value of T, so that when you multiply it by the 2450 and then add 950 will give us 83. Now at this point, I know many of you don't know how to solve equations, so at this point you could do one of two things. You could solve the equation if you know how, or you can type this into your calculator, right, into the function part of the graph, quickly go to your table using Control T, and just arrow down to your table to where you see 83 as the output. Okay? If you know how to solve equations, we can do that super quick. We're going to isolate our T. So the first thing we want to do is move all of our constants to one side. Constants are the numbers by themselves that don't have variables. So I have a 950 over on the same side with my T. That's my constant. I need to move it over. So I'm going to do the opposite operation, which means I'm going to subtract it because it's being added currently. If I subtract something from one side, I have to also subtract it from the other side. This will go away. And on the right side, we'll be left with 2450 times t. And on the left side, we'll be left with 7350. Okay? The last thing we have to do to isolate our t is to get rid of its coefficient of 2450, which is being multiplied by it. So to do that, we do the opposite of multiplication on each side, which means we're going to divide both sides by 2450. On the right side, 2450 divided by 2450 is 1, and 1 times t is the same as t. On the left side, 7350 divided by 2450 gives you 3. So t represented number of tickets, so the number of tickets they would have bought, or the student would have bought, is 3 tickets. Okay, this is an application problem of slope. We don't have a graph here, but the other way we learned how to find slope was from 2 points. Well, we don't necessarily have 2 points explicitly, but we do have a table of values. So basically what we have, whenever you have a table, basically you have lots of points to choose from. The cool thing about slope is I can choose any 2 points from a linear function to find the slope. It doesn't matter which 2 I choose. So I can choose whichever ones I want here. I think I'm going to choose just these first 2. Okay? X is on the left, Y is on the right. So let's go ahead and we're going to use our slope formula. Remember, we're subtracting our Y's on the top and subtracting our X's on the bottom. I get to choose the direction that I want to subtract. My 2 Y values are 202 and 184. So I'm going to choose to do 202 minus 184 on the top. So I took the top point minus the one below it. I'm going to do the same order on the bottom. I'm going to take the top X value, which is 10, minus the one below it, which is 20. Now all I have to do is simplify. So 202 minus 184 gives me 18 on the top. On the bottom, 10 minus 20 gives me a negative 10. So this slope is going to be negative. Now I just have to simplify. I know I can divide the top and the bottom number both by 2, which will give me 9 in the top, 5 in the bottom. I already have a negative in the bottom. If I wanted to move that to the top, cool. If I wanted to put it in front of the fraction, also cool. But this is the slope. Now if I put units with it, remember my top value were my Y values, which were feet. So I could say that this elevator is changing by 9 feet. It's going 9 feet, and my time is on the bottom, so that's 5 seconds. And because it's negative, that means it's going down 9 feet every 5 seconds. So once you add the units to a slope, sometimes it has a little bit more meaning in a problem situation. All right, we kind of talked about this a little bit. When your equation is y equals a number or x equals a number, you're going to find that number on that axis. So here's our equation, y equals negative 6. Here's the y-axis up at the top, or the vertical axis. I'm going to go to negative 6, which is down here, and I'm going to just draw a line straight through it. This line represents y equals negative 6. Just to reiterate, it has a slope of 0 because it's flat. So any flat line that has a slope of 0 will always have the equation y equals whatever value it crosses through on the y-axis. Now we're going to look at kind of the opposite of that, and that's when we have an x equals equation. This is we're going to find 7 on the x-axis, which is right here, and we're going to draw a line straight through that. This is the graph of x equals 7. X equals 7, x equals anything will always be a vertical line, and it'll always have no slope or an undefined slope. So here are some conceptual questions. that will help you when you are trying to solve the problems with respect to some number values or some graphs or some tables. A relation is just when two quantities or two variables have some kind of relationship. Quantities. Sorry, I can't write. They'll usually be paired up. The two quantities, they can be represented as ordered pair, as in a table, in a function rule, or in just an equation, if it's not a function, or as points or a line on a graph. If your relation is in the version of a table, which means basically it's just a bunch of ordered pairs, you can tell if it's a function if the x's do not repeat. X does not repeat. So I wouldn't want to see in like a table, if I had x, y, I would not want to see 2 gives me 1, and then C2 again gives me a different number. This would not be a function. Okay. Now let's talk about a mapping. To tell if a mapping is a function, you want to make sure that in the x part, every number in the x part has only one arrow coming off of it. So like if I had something like this, I'm just making this up, I would want it to look something like this. That would be a function. Now if one of these numbers on the left, I don't care about the y's on the right, if one of the numbers on the left had like a second arrow coming off of it, this would not be a function because that x value of 2 would have 2 y values, which is what we don't want. So you're looking for an x with only one arrow each, or however you want to word that. Okay. Now from a graph standpoint, to tell it if it's a function, we always do the vertical line test. So we'll do that here in just a minute so you can see what that is. But basically, if you draw a vertical line anywhere on the graph, it should only touch the graph one time. If it touches it more than once, it fails. It is not a function. All right, this is a sequence question. We didn't really get to talk about this in class. We'll kind of talk about it before the test. So here's how it works. And it can be, they can be presented in different ways. They can be presented as a list, or they can tell you the position of each number in the list. So right here we have a of 1 equals -7. That basically means the first term is -7, like that. And then it jumps to a of 3 equals -1. So basically there's a number, the second number I don't know, but the third number is -1. Then it jumps to a of 5 equals 5. That means the fifth number is 5. I don't know what the fourth number is, but the fifth number is 5. And then it also gives us the sixth number as 8. So basically I've got 1, 2, 3, 4, 5, 6 numbers, or 6 positions. I don't know the second one, and I don't know the fourth one. But you don't have to know every term in this sequence. And this sequence could keep going, right? I could keep adding terms to my sequence. But they're following some kind of pattern. So what you're looking for here is you have answer choices. It says which equation basically describes the pattern. Will help you find any term in the sequence. So the ends in each one represent the position. Okay? So that's kind of like your x. The terms in the sequence, which are on the top here, the ones that were given, those are kind of like your y's or your output. You can kind of think of it like that. So what I like to do is use this strategy called pick 3. And the way that it works is like this. Look at the third term. if you don't have a third term, look at a term past 3. The reason why this is a best practice is because if you use the first term or the second term, sometimes those, more than one of the equations will give you the same first or second term, so it's not really enough information. Usually you'll have to go on to the third or fourth term anyways to just verify. But if you jump straight to the third term where your n value is 3, right, then all you have to do is plug it in and see which equation gives you an output of -1. So here's how it works. Oops, sorry about that. So let's look at answer choice A. I'm going to put a 3 where the n is, so it's going to be like this. 2 times 3 minus 9, and I'm going to evaluate that. 2 times 3 is 6, 6 minus 9 is -3, but I want an output value of -1, so this is not going to be my answer choice. Try the next one. Again, we're still using 3 as my n. 3 times 3 minus 10. Let's evaluate that. 3 times 3 is 9. 9 minus 10 is -1. Yes, that works. That might be our answer. I don't want to pick it just yet because there might be another answer choice that also gives us a -1. So let's keep going. Choice C. I've got 4 times 3 for my n minus 11. 4 times 3 is 12. Minus 11 equals a +1. That's not the output I'm looking for, so I can eliminate C. And try it again for D. D is n squared, so that means I'm taking my 3 and squaring it, and then subtracting 8. 3 squared means 3 times 3, which is 9. 9 minus 8 equals 1. That's not my output value that I want there, so I'm going to eliminate D. And I verified with each answer choice that B is the one I want to look for. If you want to make absolutely sure, you can try another input-output pair. Try to input 5 and see if it gives you the output of 5. It totally should. 3 times 5 is 15, minus 10 is 5. So just to double check, that's how that works. Alright, now we're looking for functions. In this one, from a graph. This is where we use the vertical line. If I draw a vertical line anywhere on the graph, and it crosses it more than once, it is not a function. I have crossed it here and here, so this is not a function. When you have a list of ordered pairs, or you have a table, you always will have an input and an output, or your x and your y, right? These are all x's and y's. Remember, for functions, we're looking for an x value that does not repeat. So we're looking at the first term, or the first coordinate in each ordered pair. I see that my zeros both repeat, so that means this is not a function. In a mapping, the way that you tell if you have a function is you look at the x, or the domain part of things. You don't need to worry about the y, and you're looking to make sure that none of those have more than one arrow off of it. Well, the -3's got 3 arrows. The 10 has 2 arrows. So this is not a function. When you have a table, you're looking at just the x, or the input part of your table, and you're, again, trying to make sure that none of those values repeat. Well, I've got 5 2's. They all give me a different y output. This is not a function. I don't want to see any of the x values repeating. Alright, we're to the last problem. This is a story problem, so sometimes you have to think a little bit harder about these. They're a little more challenging, but we will get better at these throughout the year. It says Carlos is purchasing candy bars for each of his 8 friends. Each candy costs $1.50. Is this discrete or continuous? Well, let's think about this for a second. Sometimes making a table kind of helps, right? So I have an input and I have an output. If you think about the two quantities, we've got number of candy bars and we have the cost of the candy bars, right? The cost depends on how many candy bars I buy, right? So the bars are my x. This is number of bars that I buy. And it says candy bars for each of his friends. So I'm going to assume that he's getting 1 for each of his friends. Our output is going to be the cost. So the more I buy, the more it costs, right? So if he buys none, right? If he buys none, the cost is 0, right? But it says that he is buying some. So, and for each of his friends, right? So if he buys 1, it's going to cost $1.50. If he buys 2, it's going to cost double that, or $3. If he buys 3, it's going to cost another $1.50. So now we're up to $4.50, right? And it just keeps going and going. So I can continue my table. But if he buys all 8, basically, that's 8 times $1.50. So on the high end, if he buys all of his friends a candy bar, that's going to cost $12. Okay, so this just kind of helps us organize the information. So it wants to know, is this discrete or continuous? Well, I can't buy half a candy bar. I can't buy part of a candy bar. I will never pay, for example, $2. That will not be a cost, because that would be like a candy bar plus a little bit. So if I was to graph this, I would not want to connect my points. They would be individual points, which means we would have a discrete graph. Discretes kind of look like scatter plots. Now let's talk about the domain and the range. The domain, remember, are x values. In this case, represents candy bars. 1 per kid, and I got 8 friends. That means I'm going to buy between 1 and 8 candy bars. And because it's discrete, I'm looking for a list. So the only answer choice that makes sense here is B, a list. I would only use the inequalities if it was a continuous graph. Let's look at range. Range are our y values. So now I'm looking over here at the other column. On the low end, it's going to cost me $1.50. On the high end, it's going to cost me $12. But again, because this is discrete, I'm looking for a list. The only one that is a list is D. Okay, so those are the review problems. If there's anything that I explained that you're still struggling with, just put a star next to it, and then right before the test, I'll give you a little bit of time to fill out your note card, and then you can ask me any questions that you have, or you're welcome to come to tutoring. All right, happy studying.